A crystal of the purple compound called potassium permanganate 7. It's a purplish crystal, and potassium permanganate 7 is also soluble in water. So it's placed at the bottom of a beaker of water, and the beaker is left there until there is no further change. So what would be observed, right? So the potassium permanganate 7 crystal is going to dissolve into the water, and then since it is going to dissolve into the water, and we know that all the particles would be in continuous random motion using the internal energy, right? Diffusion occurs when particles use their internal energy to move from one place to another. So the potassium permanganate 7 crystals, which is their purplish coloration, is going to use its internal energy to move throughout the liquid. And both potassium permanganate 7 particles and as well as the water molecules would diffuse into each other to produce a uniformly purple solution throughout the beaker. So what we're going to get is a uniformly purple solution. A colorless liquid with purple crystals remaining unchanged would happen if potassium permanganate 7 crystal is not able to dissolve. But we know that potassium permanganate 7 crystal can dissolve in water. A purple layer below a colorless layer, if that were to happen, then we know that diffusion is not occurring and that the particle is not moving. In fact, we will end up proving that the particulate nature of matter, where the particles possess internal energy, is not true. So that's why option C is not going to happen. Colorless layer below a purple layer for the same reason is not acceptable. So hence the option A is the correct answer.